guys, welcome to this new video. In this video we will be discussing about some of the topics that are not given in this Excel sheet, and that topics are required for our knowledge so that we can apply those in other further topics given in this Excel sheet. So with no further delay, let's get started. So first of all, we will be discussing about little and big endian, that are actually two methods of storing multi-byte data in the memory, and nowadays these are actually merged into bi-endian as well. But first of all, we will see little endian and big endian, then we will jump to bi-endian. So the funny thing is that this little and big endian device, this derived their names from the Gulliver Travels novel, where like let me talk about it in the last. So first we will see what these are. So basically these are just the two ways to store multi-byte data types, and as you know that we have different types of processors like Intel, ARM or Motorola. These have to follow some rule to store the data in the memory, right? So for storing that, they actually use either of these two methods. So in little endian machines, what happens is that, let's say you have an integer representation, okay, and um, you have an integer representation and it takes 4 bytes in the memory, okay. So in the memory, let's say 0 1 2 3 4 5 and 6 7 is the representation of some integer in that 4 byte, and it is stored at these addresses: 0x100 address, 0x101, 0x102 and 0x103. So in the little endian thing, when a processor follows little endian method, so it will kind of store the values in descending order, but it is not actually, we cannot call it a descending order, but we have to call that it will store the first byte of the binary representation last in the memory, okay. And big endian devices, they store the first byte of their of the binary representation of data, of multi-byte data, first in the memory, okay. So for just for learning, you can see that this is, as this is in ascending order, that is from smaller to bigger number, so we will have this big endian, and for decreasing order, that is from greater number to smaller number, we will have little endian. So let's say you want to find out which machine are you running, like your machine uses which endian method, so you can run this code. So this, in this code, basically it will, let's say we have this representation of integer, and we'll get the integer address and then convert it into the char pointer, so that we can reference the last character of each and every character of this byte, so one byte at a time, and then we can print out it, okay, one by one. So just it's doing the same thing, and it will just go one by one in the memory. And if we started from, let's say, n, then went to 0 by decreasing, then we would have been pointing from right to left direction in the process, but here we are going from left to right. So in that, the big endian one will be printing 0 1 2 3 4 5 6 7 in the output, and little endians will be printing 6 7 4 5 2 3 0 1, okay. But is there any other good way to find out whether your machine is little endian or big endian? Yes, there is. So there is a small way, like quicker way. So what we have to do is, just we have to initialize an integer with 1, and if it is in the memory, the binary representation in the memory, then 0 and 0 1 will be stored last in the memory byte, and 0 1 will be stored first in the memory byte in the big endian, and the last in the little endian. So whenever the character pointer that we used earlier, we dereference it, so it will actually point to the first first single byte of the memory, like let's say 0 1 is there in the little endian, so it will point to 1, because character points to as character as having 1 byte of space, and the pointer will point to the first character in the byte. So and in the big endian it will point to 0. So if it is pointing to 1, then we can check the if condition on this, as 1 is actually considered as true and 0 is considered as false. So whenever 1 is there for little endian, it will go in the loop, in the if statement, and then print little endian, else it will print big endian. So this is a small way and a quick intelligent method to check whether your machine is little endian or big endian, correct? So these were two codes written in C++ and C, and this is just the explanation what I did. Now whether endianness matters for programmers, like it is not the issue for programmers for some time, because the compiler actually handles the endianness for us. But in the network programming it matters. Suppose let's say you write some integer file on a little endian machine, okay, and you transfer this file over the network to a big endian machine. So if there is no mechanism to convert the little endian to big endian, then the big endian machines will read the file in reverse order, and that will just mess up all the things. So we do not require that. So you can have this practical example here. So a standard byte order of network is big endian, okay. So and it is also known as network byte order. So before transferring data on the network, data is first converted to network byte order, that is big endian. So that's why it matters when you are using typecasting. So you can see a practical example here. Let's say you are having this code, and let me just make you understand from here. Yeah, so you are having this code, okay. So in this one, you will, what is happening is that you are storing an array of unsigned character in values. So you are having 0x01 and 0x00 in the array, and you are defining an integer that is pointing to this array, okay. We are printing it. So whenever the above character is typecasted into the in this integer value, then what will happen is that if we are running a little endian machine, then it will output 1, and if we are running a big endian machine, then it will output 256. That's a big difference, correct? So that's why it matters in the network as well, and we should not follow this type of code writing, because this will lead us to erroneous results. So to overcome this, because sometimes some other use little and sometimes some other use big endian, so bi-endians were introduced. So bi-endian processors can run both of these modes. So let's say you wrote in little endian and you just took that code and transferred to the big endian machine, and it supports big endian machine, then it will not be correct. But let's say you are having a bi-endian, then it will run correct. So the main thing is that it will run both the modes. So example of little, big and bi-endian machines are that when bi-endians were not introduced, so Intel used little endians, ARM also were little endians, but now the Intel still uses little endian, and current generation ARM processors are using bi-endian devices, correct, bi-endian processors. So also Motorola 68K, PowerPC and Spark by Sun processor, these are big endians in first, but current version of these are bi-endians. Now does endianness affect file formats? So if the file format is taking 1 byte as basic unit, then they are actually independent of endianness, because if 1 byte only is there, then you either you check from left side or right side, they are always equal. So for ASCII files, they have 1 byte, so they are independent of endianness, and other file formats like JPEG files are actually stored in big endian format, correct? So which is better? So as I told you in the starting that this term was actually taken from Gulliver Travels novel, which was written by Jonathan Swift. So in there, as there were two groups that cannot agree on which end of an egg should be opened first, the little side or the big one. Just like the egg issue, there is no technological reason to choose one bite ordering convention over the other. Hence, the arguments degenerate into bickering about socio-political issues. Okay, so as long as one of the convention is selected and adhered to consistently, the choice is arbitrary. Okay, so this was Little Endian and Big Endian, and we will meet in the next video. And you can check out my playlist that I have created. So till the next video, keep watching and keep learning.